Hello everyone, this is K. Bharat Chandra from 3rd BTech ECE department. Today I am going to discuss about the topic filtering of long data sequences overlap add method. First, let's know about linear filtering. What is linear filtering? Linear filtering is processing of input signal to get an output signal. And you know how linear filter works on signals. There is a linear filter which impulse response is h of n and let x of n be the input to the filter, and then the output y of n is given by y of n is equal to x of n convolution of h of n. Linear filtering results in the convolution operation of input signal x of n and the impulse response h of n of the linear filter. Here, in this case, the input x of n will be the long data sequences. In practical scenario, we need to calculate the convolution of very long data sequences, and the overlap method is one of the methods for filtering of long data sequences. This method allows us to use the DFT based method when calculating the convolution of very long sequences. In this overlap add method, the input x of n will be segmented into subsequences of limited size. Why the long sequences should be segmented into limited size of blocks? Because of limited memory of digital computer, long data sequences must be segmented into limited size blocks for processing. And there are some steps to follow to do this method. Assume that h of n of the linear filter with length m is given and x of n be the long data input sequence, which will be the segmented into blocks. Step 1. Select the value of n is equal to 2 power m, and if the value of n is mentioned earlier, then there is no need to select like this. N is equal to 2 power m. We know that n is equal to m plus l minus 1. Here n is the length of the subsequence or segmented blocks of x of n. Now after selecting the n, we have to find l. And next, the second step. Here we have to make the length the h of n length as n by padding l minus n zeros. We know that the length of the h of n is m. If we want to make the h of n length, and then we have to add l minus 1 zeros to it, so that then the length of the h of n will be n. After that, we have to divide the long data sequence x of n into subsequences of each length n. Here x1 of n, x2 of n, x3 of n, these are the subsequences of x of n. Here see, we have to take l values from the x of n, and we have to add m minus 1 zeros to make the length of x of n n. After getting x1 of n, x2 of n, x3 of n, we have to do circular convolution of every subsequence with h of n. Here x1 of n convolution h of n gives y1 of n, x2 of n convolution h of n gives y2 of n, and x3 of n convolution h of n gives y3 of n, and so on. After getting the y1 of n, y2 of n, y3 of n, y4 of n, we have to add the m minus 1 data here and m minus 1 data in y2 of n, and we have to add them, and we have to write the resultant values here to get final output data sequence of y of n. We have to write the samples here as it is, and we have to add these samples, and we have to write them here, and we have to write these samples as it is, and we have to add these samples, and we have to write it here. We have to do like this. Let's take an example. Here given x of n is given and h of n is given and the value of n is given. We know that n is equal to m plus l minus 1. Length m is the length of h of n. Here h of n length is 3, so m is 3. Therefore l is equal to 3. We have to add l minus 1 zeros to h of n, so that the length of h of n will be 5. Therefore therefore the resultant h of n will be 1 comma 1 comma 1 0 comma 0. Now take x of n and divide it into subsequences of each length l. First of all, take x of n and take l values, l samples from the x of n. Here l is equal to 3, so we have to take 3 samples, 3, 2, 0, and we have to include 2 samples to make its length n. N is equal to 5. Here the length of the x1 of n subsequence is 5 samples. Similarly, we have to do with x2 of n. Here we have to take next l samples from x of n, and after that we have to include m minus 1 zeros. Similarly, x3 of n and x4 of n. Here x4 of n, the remaining 3 will be taken, and we have to add remaining zeros to make its length 5. After getting x1 of n, x2 of n, x3 of n, x4 of n, we have to do circular convolution with h of n individually. Like x1 of convolution of h of n gives h of n gives y1 of n, and x2 of n convolution of h of n gives y2 of n, and x3 of n convolution of h of n gives y3 of n, and x4 of convolution of h of n gives y4 of n. Now after doing the convolution, we get the sequences of y1 of n, y2 of n, and y3 of n, and y4 of n. Now we have to get the output sequence from these 4 subsequences. Here we have to write these 3 samples as it is, 3, 5, 5 here. Now here last m minus 1 samples of y1 of n and first m minus 1 samples of y2 of n. M is equal to 3 and m minus 1 samples are 2. Last 2 samples and first 2 samples of y2 of n, last 2 samples of y1 of n should be added, and their resultant will be written here. Here 2 plus 1 is equal to 3, 0 plus 5 is equal to 5, and this 8 will be written as it is. And similarly, y2 of n last 2 samples and y3 of n first 2 samples overlap each other, and we have to add them and we get 9 comma 6. So we have to write 9 comma 6 here, and we have to write 5 as it is. Similarly, we have to do this. We get 6 comma 5, and we have to write these samples as it is. Here this is the output data sequence y of n, and this is the procedure to the overlap add method, filtering of long data sequences. What we done here is dividing the long data sequences into subsequences, and by performing circular convolution of these subsequences with h of n, we get y1 of n, y2 of n, y3 of n, and y4 of n. After we get resulting sequences, by overlapping these sequences and adding these m minus 1 and m minus 1 samples, we get the y of n. This is the whole procedure to do the overlap add method of filtering for long data sequences. Thank you.